Let's try this one more time. So we are talking about numbers and percentages. And the idea is that when we talk about numbers and percentages, we want to kind of get a better understanding about numbers. And with percentages are very important in terms of us understanding how to compare different things in particular. Because many times it's more useful for us to know how something changes in percent rather than just knowing how something changes in the actual numbers. So these are some of the things we're going to talk about right now. So starting off, there's this idea of scientific notation. And scientific notation is basically a method of writing numbers that are really, really large or really, really small in a way that's more succinct and compact, right? And the idea is that we're taking a really, really large number and we're going to write it as one single digit with some decimal points, some decimal places, and we're going to multiply it by some power of 10, right? So you all know if you take 15 and you multiply it by 10, what do you get? 150. And if you multiply that by 10, you add another 0. Every time you multiply by 10, you add another 0. Another way to think about it is that every time you multiply by 10, you move the decimal point over one space, right? So every time, let's say we have 0.15 and we multiply by 10. When we multiply by 10, we move the decimal point over. We multiply by 10 again, we move the decimal point over. And if we keep multiplying by 10, we keep moving the decimal point over, right? So the idea is we can use that idea to kind of shrink numbers down and have that multiple of 10 in there instead of writing out the whole number. And one of the things this lets us do is it lets us compare numbers quicker, right? Because it's like when people say, oh, I make 6 figures versus making 5 figures versus making 7 figures, right? You automatically know who makes more money because you know basically how many zeros are behind that first number, right? So with that, it makes comparing numbers easier. And that idea of basically how many zeros are there, right? That idea is kind of what we call the order of magnitude. And the order of magnitude is basically how many places there are in the number, right? How many places are there, right? Or kind of like how many zeros are there? Are we in the hundreds? Are we in the thousands? Are we in the 10,000s, the 100,000s, the millions, right? Where are we in terms of the scale? So let's do some examples and kind of see how we go about actually writing things in scientific notation, right? So first thing we need to know about scientific notation is that we are, like we did here, we took this number here and we moved that decimal point over a bunch of times and we rewrote it like this, right? That's what we're trying to do. And over here, we took a small number, this number here, we move the decimal point over some number of spaces and we write it like this. So what I'm going to do, I'm going to actually go through some examples and kind of go through what exactly it is that we are trying to do when we actually move the decimal point over and how we can go about doing that, right? So to start off, let's take a really, really big number. We're going to take 5, 7, 6, 3, 2, 4, 1. We'll take this number, right? And the first thing that we need to do to write a number in scientific notation, we need to ask ourselves, where does the decimal place want to go for it to be in scientific notation? So where do we want to move the decimal point to? So where to move decimal point. Now, for something to be in scientific notation, we want only one non-zero digit to the left of the decimal point. So where could we put the decimal point in this number so that only one non-zero digit was to the left of the decimal point? And the idea is that if we somehow were able to move our decimal point right here, right? We move our decimal point right here. What would be the digit that's to the left of it? The only digit that's to the left of it, that way it's to the left, is a 5. We have one non-zero number to the left of the decimal point. So that's the first question. Where do we want to move the decimal point? And we want to move it here in this case. It'll be a different place depending on what problem we're doing, but that is the first question. Now, after we say where do we want to move it, we need to say how many spaces, right? And in which direction? So how many spaces are we moving it, and in which direction are we moving it? So where's the decimal point start off in this number? Where's the decimal point at now? In 5,763,241. Where's the decimal point at?
Is it between the 5 and the 7?
No, that's where we want to move it. Where does the decimal point start off at?
So would it start by the 1?
Yep, like right here. So when we start off, if we don't see a decimal point, we can just put a 0.0 at the end, and that kind of shows us where the decimal point is. But the decimal point, if there is no one showing, the decimal point is all the way to the right, so all the way at the end of the last number. If we don't see it, if we see it, then we already know where it is. But if we don't see it, that's where it is. So how many spaces and in which direction would we need to move it to get it to that place where the arrow is? So let's count. We're gonna go 1, 2, 3, 4, 5, and 6 spaces. So we're going 6 spaces. And in which direction are we going, to the left or to the right?
The left.
6 spaces to the left, exactly. So that's the question. How many spaces in which direction? So we went, and I'll write it permanently here. 1, 2, 3, 4, 5, and 6. So we went 6 spaces to the left. Right? And both of those things will be important. Right?
Is it possible you can like zoom it out? It's kind of wide. So we don't see the 5. At least I don't see the 5. I don't know.
You don't see the 5? What do you mean?
Like I see the 3, 2, 4, 1, but I don't see the 7 or the 6, 7, and the 5.
Okay, what about anyone else?
I can see it.
I can see it.
What do you see now? Camille?
All I see is the left. Oh, now I see the whole thing.
I think it's something going on your end, Camille.
I can see it now.
You can see it now? Okay, maybe there was just something weird going on.
Yeah.
All right. So the 6 spaces tells us one bit of information, right, that we need to write it in scientific notation. And the to the left tells us another bit of information. Now, if we look back over here, we can see that there were 2 parts. There was this number part and this multiple of, not power of 10, not multiple of 10, power of 10 part, right? So those 2 things are important. So the 6 spaces tells us what the exponent on the 10 will be, right? And the to the left is telling us how many times to count the exponent up. So we're going to rewrite this and say we're going to put the decimal point in the place that we moved it to. So we moved it between the 5 and the 7. So we're going to say 5.7. We're going to just rewrite the whole thing, but usually we would like round off part of it. So we'll write that whole thing. And then we need to put a times 10. And then the power is going to be the number of spaces we counted. And if we count it to the left, we go up. If we count it to the right, we go down. So in this case, we count it to the left, so our power is going to go up. So that's going to be, the exponent's going to change, and it's going to be 10 to the 1, 10 to the 2, 10 to the 3rd, to the 4th, to the 5th, to the 6th, right? So we have our exponent as 10 to the 6th. So we ask ourselves where to move the decimal point, how many spaces and in which direction, and then 3 we rewrite number. So we rewrite number with the decimal point moved. Right? And then 4, we are writing four, and then we are going to multiply by the power of 10. Multiply by the power of 10, right? And the power of 10, if we moved to the left, we go up. But if we moved to the right, we go down. Right? So these are our steps. These are the steps we are taking to write a number in scientific notation. Right? And when we go up or down, if there is no power of 10 already visible, right, then when we go up or down, we are starting at 0. Right? We're starting at 0, and as we go up and down, we move up and down from 0. Sometimes we may have situations where there is a power of 10 showing, and in that case, we start from whatever power of 10 is showing already. Right? So that's what we're doing here. So let's do another example with this. The best thing to do is just do a couple of scenarios and examples and just see what we get. So let's do another example. So let's say we have another number 3470. Right? So the first question is what? What's the first thing we need to ask ourselves? Where to move the decimal? Where do we want to move the decimal?
So is the goal every time going to be to move the decimal to where it's a non-zero number, one non-zero number to the left? That's always the goal?
Always is the goal, to move the decimal point to the place where there's only one non-zero number to the left of it. So in this case, this is the only place. So we're going to draw I'm going to draw a permanent arrow here. This is the place. One non-zero number to the left.
Which case would you where you say up and down, left and right?
Which case will we move it to the right? Well,
when you always have to go to the left, if it's always going to be one
nope.
number?
We'll show an example next. After we do this example, we'll show an example where we count down instead. Right? So we're trying to move the decimal point here. So step 2 is, we did step 1, where to move decimal. Step 2 is how many spaces and in which direction. So how many spaces are we going over? We are going over 1, 2, 3 spaces over. And in which direction? 3 spaces to the left. So we'll just write it. I mean, after a while, you won't have to write 3 spaces left. You won't have to write that part. But for right now, we're going to write it. Then it says rewrite number with decimal point moved. So we have 3.470. And then multiply by the power of 10. So times 10. And again, the number of spaces tells us, the number of spaces tells us how many to count. And the direction tells us, are we counting up or are we counting down? And in this case, left is up. So we're at 10 to the 0, so we're going to say 10 to the first, to the second, and to the third. Let's do another example. So in this example, and then I'll give you all some examples to do yourself. So in this example, we have 0.000893. Step 1. Where do we want to move the decimal? Where can we move the decimal in this number here, right? So that we have, just give me some more space, so that we have only one number that's not 0 to the left of it. Between what 2 numbers?
8 and 9.
Between the 8 and the 9. Right here between the 8 and the 9. So that's where we want to move it to. Now, step 2 is how many spaces and in which direction. So how many spaces are we moving it over? Well, we're starting here this time. So how many spaces? Let's just count it. I recommend drawing the little hoops. We're going to go 1,
2, 3,
3, 4,
5.
5. So we went, where did we go?
5 spaces to the right.
5 spaces to the right. Exactly. 5 spaces to the right. Now, when we do this 5 spaces to the right, now we need to do step 3, and you can see that this time we're going to be counting down. So we're rewriting the number with the decimal point moved. With it moved, we get 8.93. And then now we need to multiply by the power of 10 times 10. And then how did we count it? 5 spaces to the right. So we go -1, because we're starting at 0. -2, -3, -4, -5.
10 to the negative 5.
To the
So now
negative.
it's 10 to the negative 5th power. Right? So 5 spaces to the right, and this is in scientific notation. Now notice, all of our scientific notation, some number times 10 to some power, some number times 10 to some power, some number times 10 to some power. And if we wanted to quickly know which number was bigger, kind of all we need to do is look at the power. Right? That's kind of all we need to do. We just need to look at the power. And once we look at the power, that'll kind of tell us which number is bigger. The one with the bigger power of 10 is the bigger number. And the one with the smaller power of 10 is the smaller number. So let's do another example here. What if we had something like this? 0.000257 times 10 to the 6th. So we still follow our same steps. What is step 1? Where to move the decimal point. That's step 1. Right? Where to move the decimal point is step 1. Right? And where do we want to move the decimal point to? Between the what and the what? Right.
5 and the 7.
Nope.
Oh, the 2.
One number to the left of it. So that's between the 2 and the 5. We want to move between the 2 and the 5. Now we need to do what? How many spaces and in which direction?
Right.
So we're going 1, 2, 3, 4. So it's 4 spaces to the right, 4 spaces to the right. Right, 4 spaces to the right. And then the next step is rewrite the number with the decimal point move. So let's rewrite the number. We get 2.57. And then the last step, multiply by power of 10. If we go left, we count up. If we go right, we count down. Times. Now look here. Didn't we already have a power of 10 there?
Yeah.
So that's going to be our starting point. In the other ones, we didn't have a power of 10. That's why we started at 0. But in this case, we already have a power of 10. So when we count, we're going to start at 6. That's where we're going to start. We're starting at 6. So we have 10. Now we're starting at 6, right? So we're going 6 and we're going to the right. The right is what direction? Down. So we go 6 and then we're at 5, 4, 3, 2. So we count it down from 6. So if there's already one there, we count from that number that's already there. So it's still the same steps. But when there is no one there, we're starting at 0. But if there is something there, we start at the exponent that's there already. Right? So that's what we're doing there. So now this would be our number in scientific notation. So now I'm gonna give this one to you all. You're gonna take a second. You're gonna try to solve it yourself, and write it in scientific notation. So this one is, I'll give 2 of them. We have 5, 2, 3, 7, 1, 3. and we times 10 to the minus 2, and we have 0.00295 times 10 to the minus 7. So these are the two that we have. I want you to take a second and try to see if you can solve this and write it in scientific notation yourself. Okay? So go ahead and try. Try to write these two in scientific notation. And then we'll come back and we'll do it together. All right, are you all ready for me to try the first one?
1 second. Okay.
All right, so let's try the first one. For the first one, what's step 1? Where do we want to move the decimal point? Now we want it so that there's one number to the left. So the only place would be between the 5 and the 2. Now how many spaces do we need to move it over? Let's count how many spaces in what direction. 1, 2, 3, 4, 5. So 5 spaces, and we went which way? Left. 5 spaces to the left, right? So now step 3, rewrite the number. We get 5.23713. Now you can round it off. So we're going to actually round this one, and instead of 5.23, we're going to round it right here, and we're going to put 5.24. That's what we're going to put instead. We're going to round it and do 5.24. And then now multiply it by the power of 10. So times 10. Now we got to see what the power is. We're at -2 already. See, we're at -2 already? We're at -2. So when we count, we're counting from -2. And since we went left, which way are we going? Up.
Right.
So we went left, so we're going up. So we're at -2. Going up is -1, then 0, 1, 2, and then 3. So we end up at 10 to the third. And that's that one in scientific notation. Now let's do the next one. So for the next one, first we need to say where are we moving our decimal point. We want to move it between the 2 and the 9. That way the 2 is the only number to the left of it. Then we count how many spaces in which direction. 1, 2, 3. Then we rewrite the number 2.945. And we write our exponent, our power of 10. So 10 to the -7 is where we're starting. And we went, I didn't write my 3 spaces to the right. And to the right means we are going up. So when we count our 3 spaces, we're counting, I'm sorry, to the right means what? Down. I said up. See? To the right means down, left means up. So we're counting our 3 spaces down, and that's that -7 is our starting point. So we go -7, we're counting down. So then we go -8, -9, -10. See how we did that? We're counting down from -7. Alright, counting down from -7. And so that's going down from a negative number gets a bigger negative number. So -7 -8 is next after -7. So we ended up at minus 10. And that is this one in scientific notation. Scientific notation is not like super difficult or hard or anything like that. It's just about following these steps. That's what scientific notation is. Follow these steps. All right, follow these steps and you'll be able to do it. So moving on from scientific notation, another idea is significant figures. Significant figures tell us about rounding. What I would do is I'd send you all some other slides and some videos and stuff that you can watch on significant figures, but everybody always has that question on how do we round some numbers off. So there'll be some other stuff that I send you that will go over significant figures. But that's what significant figures. It tells us how to round. Now let's talk about percentages. So percentages can do a couple of different things. They can demonstrate fractions, describe change, or we can do them as comparisons. If they're demonstrating fractions, let's say our class was 6 people in the full class. If only 3 people are present, right, we could say 50% of the class is absent. Right. Describing change, we could say something increased by 30%. So and so got 25% taller. Right? That's describing a change. Or we could say use it as a comparison, and we could say person A has 40% more money than person B. Right? So these are different ways that we can use use percentages just to describe different things. So the first thing we're going to look at is what we call absolute and relative change. For absolute and relative change, the first thing is that looking at that word absolute. And absolute means like the actual amount, right? Like the actual number. So if you increase by $5, the absolute change is $5 because that's how much you increase by. So absolute always, in every term, when you see the word absolute, it means the actual number. And to find the absolute change is as simple as doing the new value minus the old value. That's how simple it is. New value minus the old value. Now, relative change, right, is when you are looking at relative change is when you are looking at the percent, right, or the fractional amount that something changes, right? That's what you're looking at. Or the fraction that compares the absolute change with whatever your reference value is or your old value. And to do the relative change, you do the absolute change divided by the reference value. The reference value is just whatever value you are comparing something to or whatever value you started with, right? So in essence, what you're doing is the new value minus the old value divided by your reference value. And what you can see that this actually looks like our total return formula. Total return is telling us the relative change. Because our total return was what? Total return was A minus P divided by P times 100. And again, the times 100 just turns it into a percent, right? Where A is what we end up with, or the new value. P is what we started with, or the reference value. And then we're dividing it by the reference value again, P. So the total return is actually just telling us the relative change, right? That's what it's telling us, the relative change in our money. So it's a very simple formula. All you need to know is the new value and the old value. That's all you need to know. Now, the absolute and relative difference is almost exactly the same as the absolute and relative change. The only difference between the change and the difference is with a change, you are comparing something to itself, but with a difference, you are comparing something to something else, right? With a change, you're comparing something to itself, but with a difference, you're comparing it to something else. So to find the absolute difference, you do the compared value minus the reference value. The reference value is always going to be the thing you care about, right? That's going to be the thing you care about. What you care about. Right? That's your reference, is what you care most about. So if you're comparing your salary to someone else's salary, the reference value would be what? Your salary, because that's the one you care about more. Right? So the absolute difference is just like the absolute change, and that is just the compared value is just some simple subtraction. And the relative difference, on the other hand, is actually exactly the same as well, where it is just some subtraction. Equals minus. I don't know why some of my things just disappeared on me, but this is the relative difference. We're doing compared value minus reference value divided by reference value. So only thing that's new here is that we're doing compared value instead of new value, right? Because we're comparing two different things versus comparing a new state of something with an old state of something. But both of these things are like almost exactly the same. Now another idea with percentages that becomes really important is this idea of or more than, right? And obviously when we do more than, we could also say less than, right? So let's go back over here and look at what we mean when we say of or more than. So if we say something is such and such percent of something, of always means multiply. So when we say of, we can just multiply the percent and get the answer of what the percentage is. So let's say we say the bag will cost 50% of the original amount, right? So if the bag cost $150, right, and it's 50% of the original amount, so 150, so we'll say 50% of 150, we can just multiply. So 0.5 times 150. Of needs multiplication, right? That's what it means. And then when we do that, we get 75, and this is the cost of the bag. Now, what if we said something like tax is 10%, right? Tax is 10% of your purchase price. Now, when you calculate something, if you go to the store, you want to find out how much you need in total, you don't really care how much the tax is separately. You care about how much your total will be. So if tax is 10% of the purchase price, let's say your bag or whatever costs, we'll use the same $150, and we want to find how much we're going to pay in total. If we just do the 10% of the 150, what are we going to get? Well, we're going to get, right, if we just do 10% of 150, we get 0.1 times 150, which equals $15. But we're not paying $15 for the bag. That's just telling us how much we're going to pay in tax, right? That's all it is. That's just the tax. We want to know the total, though. So what do we need to do? We need to add, exactly. We need to take the tax and add it to the purchase price, right? Or, in other words, what we need to do is we need to say that your total, right? Total will be 10%. Notice what I do here. More than the purchase price. Right? 10% more than the purchase price. And when we say this more than includes in the addition. That's what more than includes. It includes the addition in there. Because when we do more than, we can't just multiply. When we do more than, what we do is 100 plus the percentage, right? So if it's 10% more than, it's going to be 100 plus 10% of the purchase price. That's what it's going to be. 100 plus 10% of the purchase price. So this is where more than comes in, and it gives us a little more, because with the more than, we have to add in this 100, right? And we do 100 plus it. And the idea is that this 100% is what you're paying for the thing, and this 10% is the tax. So you're basically doing what you pay, right, plus the tax. Right? That's what you're doing. What you pay plus the tax. And what you end up getting out is 110% of your purchase price. Right? So that's what we're doing here when we do more than. So anytime you see more than, you need to do 100 plus the percentage more. Right? See, 100 plus the percentage more. And if you see less than, it's similar, except you're doing 100 minus the percentage. So if you say something is such and such percent less than some amount, you do 100 minus the percentage. Right? 100 minus the percentage. So that's of and more than. If you just see of, you can just multiply. But if you see more than, you have to multiply by 100 plus the percentage. And if you see less than, you have to multiply by 100 minus the percentage. Some ways people can abuse percentages is by shifting what we call the reference value, or shifting what you're comparing an amount to. So an example of this might be a 10% pay cut followed by a 10% raise. So let's look at this really quickly. Let's say you are making, and we'll do a big number just to kind of, let's say you're making $150,000. And your boss says, hey, we have a little promotion. We'll give you a 10% raise for a month, and then we'll take the 10% off. We'll give you a 10% deduction at the end of the month. I mean, that sounds fair, right? Because all he said was what? Plus 10%. And then we'll do minus 10%. Doesn't that sound fair? Anybody?
No, it's the same.
It's the same. I mean, you're not losing anything, right?
You're just borrowing some money for a couple of months and giving it back.
Yeah.
Mm-hmm.
Well, let's go through it and see if it actually is the same. What's 10% of 150,000? Let's do that in the green. What are we going to add?
15,000.
15,000. So we're going to do plus 15,000. Right? And where will we be? So this is plus 10%. That's what we're doing here. Where will we be? 165,000. That's good. Now let's do it in the red. Now we need to do the minus 10%. What's 10% of 165,000? You seeing the problem now?
But I thought you were saying they were going to, so they're taking 10% of the 10% they were giving them.
They're taking 10% of your new amount.
Oh, see, I thought it was they were going back to the original
Nope.
amount. And then,
They're giving you 10%, then they're taking away 10%. That's what they're doing.
okay.
Giving
Well,
you
yeah,
10%,
that's
taking away 10%. But the problem is, if you see here, what the problem is when we did 10% the first time, we did 10% of 150,000. But the second time, we did 10% of 165,000. So when we do this subtraction, we would actually be losing. I'm using my calculator.
So wouldn't that be minus 16,500?
Yeah, I did plus. I was supposed to put minus, and you get 148,500. You just lost some money because the reference value changed, right? Again, we did 10% of this the first time, but to take it away, we did 10% of that the second time, right? And that was the problem. That's our shifting reference value. Another abuse of percent, right, is saying less than nothing. So 100% is everything. You can't take away more than 100%. Right? You just can't. So if someone's saying they're going to take away more than 100% of something, they can't do that because 100% is everything. And if you take away more than 100%, you're going to be down to less than nothing. But you can't go down to less than nothing. right? So like, can you lose 200% of your weight? No, you can't, because once you lose 100% of your weight, I guess you're no longer there anymore, right? So be careful of that. Less than nothing. Things will advertise stuff like lose 500%, blah 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 blah, right? But you can't do that. And another thing is, you don't want to average percentages, right? Because the number of people might be different. So in this example, it says that 70% of the boys and 60% of the girls voted in the class voted to go to a water park. You can't say that 65% of the students did it, even though 65% is in between 70 and 60. What if there are more boys than girls in the class? What if there are more girls than boys in the class, right? If there are 100 boys and 1,000 girls, 70% of the boys is 70 of them, 70 people, and 60% of the girls is 600 people. But 60% makes it sound like it's less than 70%, but you can see that 60% of a bigger number would be more than 70% of a smaller number. So this is why we can't average percentages. So we want to be really, really careful of that. So these are some abuses of percentages, and it's kind of like our quick overview of percentages and how we can work with percentages. And yeah, so that is it for this.